Hello everyone, welcome on this new lesson. Today we will share with you how to body plot using the transfer function to plot the stepper of our driver motor for this motor. So the main purpose of this presentation is that we use this transfer function to plot the step of this motor, and then we will also using this function first of all to manipulate the body plot and to read the generate debit for each spool, and then final to read the degree of the phase of our motor. So we will first calibrate the step motor according for this micro stepper. In the next lesson, I will share with you how to calibrate this micro stepper, and then I will briefly introduce the different meaning of those value and what you can understand in this case is that what we are going to do is to choose any of this value, which mean the stepper per revolution. Simply mean if, for example, in this example we're going to calibrate the stepper motor 400 step per revolution, that means after 400 then it will step our motor, okay. Well, let us quickly rush our goals on our software in order to understand this example well. As I mentioned before, it's possible for you from the command link to directly call Simulink page, and then we open the new workspace. Well, after create a new project, what we must come from this option from the source, and then choose the stepper, this element, drag into your interface, and then we also need the transfer function. Where is it located? It's located in to the continue function. We need the transfer function. We drag it into our interface, and then we need to display the curve our expression, right? Yeah, so in this case I need a scope to display my function. Let us drag into, okay, and then drag into the scope. Well, the very important things here is to calibrate this thing. So how to do it, how to operate? First of all, in this section is written the step time. Simply means, for example, if I enter 2, that means after 2 seconds, then my motor will step for this value. The initial value will be 0, and the final value will be 400 step, right? and then we might input our transfer function. Our transfer function, as you can see. And then that is not finished. The keyword of this presentation is that from here you must select, let us name it here step or step motor. The main important here is that we want to plot also the linear curve of this motor. So you need to select from the linear analysis and then choose the input perturbation. Simply means it will generate the step of your motor, right? And then from your transfer function you should also select the output. For example, let us run and see the result. As you can see, that is not too it's not really perfect. So we must select this option, the linear analysis point, as the output loop, as the open loop output, right? And then run it. Well, now we want to read the body plot of this transfer function and also for this step motor. By doing this, you should come from this option and then control design, then linear analysis. Well, in this figure we have too many choices. The first one is to plot the step of our motor. Yes, right, as you can see. Okay, and then the next one can plot now the body of this function. As I mentioned earlier, we need to plot the magnitude of this stepper. So these are the dose value of our magnitude. Okay, and the information here is that, for example, let us say let us read the value of this curve. Simply mean the step of this transfer at the frequency 31 region per second. The dB of this stepper should be negative 10 times 0. Let us show in degree so that we can more see clear this curve, so that we can more read exactly what we want. Okay, and then let us read the value of this point. The value of this point. So once the motor is started to run at this frequency, then the dB of it should be this value. And then for the phase, this is the phase of the motor. It's nothing than the degree. So it started from the 0 to negative 45 degree, and then negative 19 degree, and those values are the frequency per second. So you start from log of negative 1 and 10 and 1000 frequency per second, radian per second, 10 radian per second, 100 radian per second, and then 1000 per second. Those are the frequency. And if we have, for example, 6 motor, we can also plot the different phase of that motor. So at this point, the motor will be run on at 9.4 radian per second with the with at this phase negative 43 times 2, right? And you can also rename this figure as sorry, you can also rename it, edit the title like step motor, right? And then another important things here again is you can also come from here and see from the scope the value. So as I mentioned earlier, it simply means that it starts from 0, then after 2 seconds it step going quickly of our value, right? And then to make it more interesting, you can also multiply the value of your step. Like for example, if we input 20 here, then what happened after all? You can see you can generate the double of the value. Wait. What happened after W this value? Yeah. So the result will be the same. Yeah. So that is the simplest basic information that we may know on this lesson. And do not forget to select those options in order to see the graph and see how the curve generate, and also read your information as you need. Okay, so these are the different options that we may also consider from this presentation. I do hope this lesson will be very interesting for your research. And if you are new here in this channel, don't forget to subscribe. Thank you and see you in the next lesson.